Thanks for attending our webinar about solar systems for power over Ethernet devices. This is Mark McHenry from Morningstar. I'll be your moderator for today's session, and today's presenters are Rebecca Sanchez, Vice President of Sales at Solarflexion, and Rob Rollo, President of Solar System Services. We're going to be recording this broadcast, and we will email you a link to the recording before the end of day tomorrow. And we've also included a copy of this slide deck in the handout section of your GoToWebinar pane that you can go ahead and download right now. As you listen to the webinar, feel free to type any questions that you have in the questions chat on your GoToWebinar console. We'll address as many questions as we can as time permits. And if we don't get to your question before the end of the webinar, we can address it by email. All right, let's go ahead to the next slide and look at the agenda for today. We'll start off by introducing the companies and presenters for this webinar. We'll then explain what PoE is and the electrical loads involved. Next, we'll cover WAVE PoE, components and standard systems, followed by maintenance and troubleshooting. And then finally, we'll get to the Q&A session. All right, so we'll take a look at next slide, and let me just take 20 seconds to share some information about Morningstar. Since 1993, we've been supplying charge controllers and inverters throughout the world in industrial and residential applications. And we have the widest charge controller product line and lowest hardware failure rate in the industry. So Morningstar designs and supplies charge controllers and inverters that Solarflexion distributes to customers. They distribute them individually or in kits that also include modules, batteries, and other components. And Solarflexion partners with Solar System Services to provide outstanding customer support and consulting services for those customers. All right, so with that said, let me hand off to Rebecca Sanchez so she can take herself off mute and then tell us more about Solarflexion and power over Ethernet solutions.
Awesome, thank you, Mark. Hello, everyone, and thanks for joining us today. As Mark mentioned, I'm Rebecca, Vice President of Sales for Solarflexion. We're located in Murrieta, California, and we actually opened our doors in 2016 and became incorporated in 2019. Our team has over 75 years of combined experience in renewable energy, and we are very passionate about what we do for our industry and for our customers. Go to the next slide there. Solarflexion started as an e-commerce driven business, and that is supported by our online store where you can shop 24/7. You can visit us at solarflexion.com. And although our online platform is the foundation of who we are, we did expand our products and services and now specialize in both off-grid and grid-tie applications. Our capabilities now allow us to offer services such as system sizing, design, engineering, integration, troubleshooting, as well as product procurement. We have a strong partnership with industry leaders such as Morningstar and Solar System Services, which allows us to service a wide range of customers. With our online platform, we do work with both B2B and B2C markets, and we're always happy to help find solutions. We do realize that someone might just need one charge controller to get them out of a jam, or someone might need a complete system to get them out of a jam. So no matter what it is, we can help. Above all, our company philosophy here is to focus on our clients' needs and deliver successful solutions. As mentioned, we believe that no job or request is too small. We do know that online shopping and fast delivery drive the market, and we really do pride ourselves on being fast, fun, and friendly here. We also believe that nothing can take the place of human interaction and great customer service. So we're going to take time to listen to you, to pay attention to the details and make sure we get it right. Keeping in mind our responsibility to both the industry and our customers, we're going to take all measures to make sure we're compliant, safe, and sustainable. Our company motto here is we provide the best for our customers so we can provide the best for our families. Our goal at Solarflexion is to provide the best service, value, and support for you, our customers, because you are like our family. A little bit about the WAVE. Solarflexion introduced the WAVE remote power systems in 2018. These are integrated power systems that meet industry standards as well as your needs. What you do is you define the required load, and Solarflexion will assist with the sizing and design of your system, and then we'll make the necessary recommendations. We are compliant with IEEE industry standards, and we are also ISO 9000 certified. We can assist with a variety of power sources such as solar power, utility power, power from a generator, or even with hybrid solutions. Pictured here is a project we did for an animal sanctuary in Santa Clarita, California to power a cow brush. It was a little bit of an odd request. However, we were able to accommodate and assist our customer in getting them the power they needed. And from what we understand, the cows are happy. So it was a win-win. We then expanded our WAVE line to include power over Ethernet as part of our remote power systems. Understanding the technology and requirements for PoE allowed us to assist our customers with custom solutions in remote locations where utility is non-existent. Again, you can visit our site at solarflexion.com and you can actually see some live footage of one of our PoE systems in action. So where do we start? You tell us what PoE equipment you're using along with load information, and we'll help with the size and design of the system. You're going to hear us talk a lot about load information. Knowing the load information is critical, and Rob's going to go over this later in more detail in the presentation. We can make recommendations on PoE equipment. We can supply it, so it just doesn't stop there. We're here to help you get the power you need when you need it. At the end of today's presentation, I'll mention a couple of special promotions we're offering to all of today's attendees. These promotions will be available through the month of May, so be sure to listen for those details. And with that, I'm going to hand it over to Rob, who will continue discussions on PoE.
Thank you, Rebecca. Thanks, Mark. My name is Rob Rallo, and I have over 30 years of experience in the solar power industry, mostly in off-grid applications. My company, Solar System Services, provides engineering support for companies for various types of solar applications, again, focusing mostly on off-grid and battery-based systems, such as standalone, hybrid, UPS, and battery-backed grid tie as well. I'm an active member of the IEEE Standard Association, as well as several other of the codes committees with regards to solar energy and battery backup. So let's actually take time to get into the meat of our presentation, which is, what is PoE, which stands for Power over Ethernet? And it is exactly that. It is putting power on the data lines that you send over a Cat5 or an Ethernet type cable. So one can imagine, though, as you're doing this, there can be issues and complications. So there are standards to follow with regards to that, to make certain that both the device putting the power on the Ethernet and the device that's taking that off are able to work correctly together. So some of the devices that can be powered by PoE, and there are numerous ones, and they're being added all the time. So this is nowhere near comprehensive, but just to kind of give you a small sampling of what's available or commonly used nowadays. Obviously, cameras are the big one. We've got the PTZ, which is pan, tilt, and zoom cameras. We got thermal cameras, infrared cameras, as well as other types of cameras. We've got communication devices. We've got radios, we got Wi-Fi, we got some modems. There are now lighting applications. A matter of fact, a lot of the, there's lighting ones that can be used outdoors on standalone, but there's a lot of now building lighting going on that's being done over PoE for industrial buildings. It's amazing how that market has grown. And there's also audible speakers too, so you can do audible things as well that way remotely. And again, as I said, there are new devices being added all the time. So I mentioned about some of the standards and being able to have devices communicate that power requirement. So there are two types of that PoE. There's an active PoE and there's a passive PoE. The active one must comply with IEEE standards. And basically, as I was saying before, there's kind of a handshake or communication going back and forth between the device putting the power on the Ethernet lines and then what they call the target device that is using that power. Now, passive PoE is a little bit different. as there is no communication going on. So the one device just puts it out there and the other device takes it. There can be issues with that. You have to be very careful about that and make certain that you've matched those up correctly. One of the common requirements for passive PoE is a ubiquity network. If you use a lot of ubiquity Wi-Fi and their radio communications, they use a lot of 24-volt passive PoE. It's very common for their networks. So let's talk just a little bit about the active PoE and the IEEE standards associated with that. The IEEE standard associated with PoE is 802.3. It was first developed in 2003 and has been updated and added on to several times. They now have several variations of that. They have the original PoE, which was only good for up to about 15 watts. That's what they originally came up with. Then they added something called PoE Plus, which would allow you to go up to about 30 watts on those lines. And then they added PoE Plus Plus, which allowed you to go up to about 45 or 60 watts. And now there's something called 4P or high power PoE. And again, sometimes these names change a little bit as they update the standard, and that's good for up to 90 watts now. And I'm not certain they're going to be able to get much higher than that. You have to kind of realize that if you're familiar with Ethernet cable, those are very small wires, and you know, the more power you put on there, it requires more current, and at some point you're going to max those out, and you're going to have issues with voltage drop and other things. So I have a suspicion at some point they're going to have to stop just because of the wires themselves won't be capable of handling that much power or current at some point. The typical PoE voltage range is 44 to 57 volts DC. Now that changes depending upon the communications. There's handshaking going on between the device putting the power on the lines, the device taking it. So they'll go back and forth and it may adjust, which is why there's a range in there. Okay, that's not the range of the power system. It's not the range of the battery. That's the range of the power on the lines as needed by the target device. I also want to point out that, and this is going to come up several times and very important to understand. I want to point out with these various PoE names, there's a type and a class and a standard associated with it, a substandard. So let's say for the 15 watts I mentioned earlier, 15 watt max, that's PoE, that's going to be type 1, class 3, standard 802.3 AF. Now, if you want to go up to say the 60 watts now, you're a type 3, and you may be either a class 5 or a class 6, and you're going to be operating with the 802.3 BT. The other one that's kind of common amongst target devices now is PoE Plus, which is going to be type 2, class 4, and that's going to be the standard 802.3 AT. I think though most of the devices generally are going to be on the AF or the AT standard, and we're going to go through some examples of this, and you're going to see that come up a lot with regards to the cameras, the radios, and things like that. So those are the two most common, but again, these higher power applications are coming as well. So they can be handled with the PoE still, and again, more being added all the time. So the standard is constantly being updated to adapt to these new requirements. Okay, so I mentioned there's a device putting the power on the lines. What are these devices? How do we do that? The two main types are an injector and a switch. Now the injector is just that. It's also known as a mid-span or a midpoint injector, and what it does is it literally goes in between that you would plug the Ethernet cable into it, and then it goes out to the target device. So it's in the middle, which is why it's called a mid-span. So it only sends PoE to that device and that device only. It does not backfeed anything else. It only goes one way. So that would be an injector, and you got a couple of different types of those, a couple of different manufacturers. Then you have the switch, just like you would have a regular Ethernet switch, and it's putting PoE out on it's all of the lines, and they can be managed differently and separately. We're going to talk about that in a little bit more. I talk about switches a little bit. Switches come in two varieties, managed or unmanaged. For PoE purposes, that does not matter, and managed or unmanaged refers to the Ethernet network and communication, so I'm not going to get into that in detail. That's whatever you need for your communications requirement, and we're going to try to just focus on the power requirements, so we're not going to get into whether you need a managed or unmanaged. Again, like I said, from a power perspective, it doesn't really matter for us. It's whatever's required for your network. Okay, so let's talk about AC versus DC. Um, as I mentioned earlier, these PoE devices, they're generally looking for DC. Again, if you go back to that the IEEE standard, it was between 44 and 57 volts DC. Even on the passive, it's typically 24 volt DC, but you may also find a 48 volt passive as well. But again, it's DC. So yeah, we get a lot of requests from people saying they need AC or they need an inverter because they need AC for their PoE load. And my response is, no, you don't. You need to just find a DC injector or a DC switch. In most cases, there are very few exceptions, and generally those are the very high power requirements. But for pretty much anything other than the high power PoE, you're going to be able to find a DC injector or a DC switch that will work for your application. Now, again, there are sometimes we just can't. We have to use inverter, or there may be additional loads on the site. We have to use inverter, but we try to work away from that and use DC as much as possible. The reason for that is that the inverter adds additional losses into it. Not only, and actually we'll talk about that in the next slide just a little bit. The other thing to point out is with these requirements that if you look at some of these injectors and switches, some will take various inputs to them, and most of them, and even some of the radios themselves, can be powered directly off the battery. So sometimes you might not even need an injector or an inverter. If you look at the specs in more detail, you may be able to go direct. And we'll talk about some of those examples in just a minute. I do want to clarify, though, what I mean by going direct to the battery. You should still have a low voltage disconnect in there and overcurrent protection, obviously, just in case the wires get shorted or something like that. Okay, as I was saying, the inverter adds additional losses in the system. Most inverters are somewhere around 90% efficient, or at least the off-grid variety. If you're talking about grid tie inverters, yeah, they're like 96, 97, whatever. But we're not talking about that. We're talking about off-grid inverters. The other thing is that you'll also find kind of a double conversion going on, which means additional losses. As I was saying, with the PoE, so if you're using a PoE injector that is AC based, we have to take that AC, invert it. So we have to take the DC, invert it to the AC, and then we have to convert that back to the DC on the PoE itself. So all of a sudden you've got all these conversions going on, and every time you do a conversion, there's additional loss. So not only do you have the additional 10% of wasted energy just in the inverter efficiency, now we have additional losses in these conversions going back and forth. So by the time you're done, you could be increasing the size of your system by 20% or more. And in most cases, again, 90% or more, you could just go straight DC and make your system about 20% smaller and more reliable because you have less conversions of parts going on in there. Now, the other thing a lot of people forget with the inverter is, yeah, there's the efficiency, but the inverter itself is a load. It has a self-consumption to it. In this example below, and again, this is not a large inverter. I think it was like a 300 watt or 400 watt inverter. It's got two different modes. It's got what they call a no load mode, which is kind of a standby mode, or sorry, power save mode, which is very small of just 90 milliamps. But if your PoE load is on all the time, you can't do that because your inverter must be on to power up that load. So then that means you're going to be using 0.65 amps at 12 volts. So that comes out to be about 7 watts. So you may have a small load, like a lot of these radios are only about 8 watts, and some of your cameras may only be about 11 watts. So now you find your inverter is as big a load as your other equipment. Again, making this, and not including, again, the additional losses we mentioned. So again, you've added cost to your system, and you've created the possible additional failure points in your system. And again, 90% of the time, it's not even needed. You could just go straight DC, save yourself some money, improve the reliability of the system, and simplify the whole design. Oh, also, the inverters take up additional space too. And generally, they're rather large, a lot smaller than some of these DC converters we have in there. So they're a lot smaller. So again, if you can eliminate the inverter, I highly recommend it. And again, in most cases, we can. I want to go through examples how we can do that. Oops. Okay, so let's get started with some of these examples. Okay, the example I've got below here is for a thermal camera, and you can note it can be powered 3 different ways. It can be powered off of the PoE, it can be powered off of DC direct, and that DC direct is 8 volts to 28 volts. So as I said, sometimes you can't go direct. Now the problem with this application is the 12 volt will be fine because most 12 volt batteries are going to actually batteries in general, for those aware of it, have an operating range. They have to have a higher voltage to be recharged, and they can be discharged past its nominal voltage. So there's going to be an operating range for that battery. Typically, a 12-volt battery may operate between, say, 9 volts and 15 volts, and say for a 48-volt battery system, you may operate from, say, 20 or 22 volts all the way up to 30 volts. So if you're operating as high as 30 volts on a 24-volt battery, and this camera can only operate the 28 volts, you've got a problem. So that may not be the best solution for that camera, but you could operate on a 12-volt system, and that would be fine, depending upon your other loads. So these are things you have to think about when you design your system. And it can be operated off of AC, but notice the AC power requirement is 20 to 24 volts, not your standard voltage. There are 24-volt inverters out, 24-volt AC inverters out there, but they're pretty rare and hard to find. Generally, you'd have to use a regular 120-volt inverter and then put a adapter on it, increasing your losses and conversion efficiency even worse with these additional devices on there. Again, more failure points, so I would not recommend that. But my point being, there are various ways to power up these PoE devices in general. So the best thing you can do is look at the spec sheet and look at that. Now, the other thing I want to point out is that you'll notice that each one of those has a different power requirement. If you look at the PoE as an example, it has a typical power requirement of 4.8 watts and a max of 11.8. And I'll talk about the typical versus max in a minute in additional examples. And you'll notice the DC direct is 6.6 watts with a maximum of 13 watts. And then on the AC was even the worst one because it has a typical 11 watts and a max of 19 watts. Volt amps, by the way, is just volt amps for an AC is the equivalent to watts. Oh, by the way, the power supply wasn't included either, so that costs extra in this device. But my point being that the PoE actually not only is a more efficient way to do it, it's efficient even in the power requirement itself. So you can save several watts just by using the power over Ethernet as opposed to going direct with the DC or the AC. So just keep in mind, these spec sheets on these devices is incredibly important. You're gonna hear me harping on that over and over again. There's a lot of information there, and you wanna look at those to figure out the best way to power up your device. I'll also point out that it tells you, remember I mentioned earlier about the type and the class and the standard? This camera also can work off of the AF or the AT standard using the type 1 class 3. That's going to become important when we start talking about the Ethernet injectors and the Ethernet switches. Okay, so keep in mind that this little power snippet on this spec sheet had so much information for us to be able to use in the design of the system. Okay, so I keep harping on this, know your load, and again, I was just mentioning, I'll get into this typical versus maximum in a minute, and it becomes even more readily apparent with a pan, tilt, and zoom camera. And again, there are various ways to power it up. We've mentioned this power options, and the key here is you want to try to size the load for its actual consumption and not the maximum output. Again, this is the typical versus the maximum. I know I mentioned the thermal camera here, but on a PTZ, a pan tilt zoom camera, you're going to find this frequently ends up, I think, I'll come up with one of those examples in a minute, but you're going to see that it's going to have a high max load versus a smaller typical load. And that's because when you're moving the camera, when the motors are moving to tilt, the pan, to zoom, or whatever, it requires more power than when it's sitting there idle. So when it's sitting there just actually being a camera and not moving, not zooming in, not moving around, it doesn't need as much power. And here's the thing. So if you size your system, say for, and again, in this example, 11.8 watts, you're going to oversize it by a factor of 2 or 3 versus the typical 4.8 watts. When the reality is that, again, if you have a PTZ camera as an example, it's not going to be PTZing most of the time. There's not somebody there with a joystick constantly moving the camera around. Typically, you're going to do that at the setup. You're going to, set it up. So I want to cover this angle of this spot and whatever it is. You're going to zoom in and focus on that area, and that's going to be it. You probably won't touch it again, unless for some reason something comes up and somebody needs to look at something and go back and review it. But for the most part, it's going to be a set it and forget it type of thing. So sizing your system again for the max load, you're going to end up oversizing it and spending more money than you need to. So keep that in mind as well. And again, most of these specs are going to have a typical versus max for those reasons, because they know that you're not going to constantly be moving the camera around. For the most part, it's going to be just, filming and not actually moving. Okay, let's talk about the some of the communications options. Here's an example of a mobile router. And again, here's just some of the power specs on it. This one actually can work on this one actually can take a 12 volt or a 24 volt direct, because again, it operates by 9 volt to a 36 volt DC range. They do recommend putting an inline fuse in there, which I would agree with them. It's got some reverse polarity protection and some other stuff on it. But I want to get back to, again, this power consumption stuff I just mentioned earlier. When this mobile modem is idle, it's like just 10 milliwatts. That's insignificant. That's nothing, just sitting there idle. But it's in sleep mode. So when it's in sleep mode, when it's idle, it's only consuming 8 watts. And typical is only 14 watts, and heavy usage 24 watts. So again, there's a huge range there from when it's just kind of in sleep mode versus idle mode versus heavy usage and typical. So again, if you size it for, say, the 24 watt load, you may be oversizing it versus, say, the typical or the idle. You may, again, be able to cut that power requirement in half and have a very reliable system without spending extra money unnecessarily over designing it. Here's another example of a mobile router. This one has Wi-Fi as well, and you'll notice the different power requirements for idle, which is 4 watts, versus the LTE cellular mode, which is 6.25 watts, versus the Wi-Fi, which is going to be 9 watts. And again, this is only can operate off the 12 volts direct because it has an operating range of 9 to 33 volts DC. So you could do, again, either 12 volts or 24 volts. And again, they recommend an inline fuse, which I would agree with. I also want to point out with this that these mobile routers usually have a direct Ethernet hardwire on them, which can plug directly into the PoE switch. I would recommend going down that path and disabling the Wi-Fi, because the Wi-Fi in this case adds an additional 9 watts, and it may be doing it unnecessarily. Now, in some cases, you may want the Wi-Fi there. You may have devices that are remotely mounted somewhere, I'm not certain, or you may just want to be able to have Wi-Fi in the area for whatever reason. So you may want that enabled, but if you don't need that function, I say disable it to save 9 watts. Again, you're now spending money for something for a feature you may not even need. So just keep that in mind when you're selecting your components and enabling these devices, because again, if you can disable some features that are power hungry and you're not using them, then do it. It'll make the system more reliable later on and cheaper. Okay, I mentioned the PTZ cameras before. Again, this one's got kind of a high PoE or a PoE plus, and I'm going to come again back to that IEEE standard. This one is using the AT, the Type 2, the Class 4, and they're recommending you can use with a mid-span injector. But you actually may be able to get away with just a regular switch, and I'll show you an example of that in a minute. But the typical consumption is 11 watts, and the max is 25 watts. And again, that's, if you're moving the camera around, it's going to be higher than if it's just sitting there filming. Okay, so let's start talking about switches a little bit. Here's a spec sheet for actually what's four different models of switches. It's the same package, but the manufacturer has various models of various applications. They've got a passive PoE, as I mentioned earlier, and they've got the IEEE active ones. This switch can actually do AF and AT, and if you remember, and if you want to go back to, let me go back just a few slides, back up to my little chart. There we go. The AF and AT again, you're looking at up to 30 watts is what that can do. The AF is up to 15 watts and the AT is up to 30. So again, that little chart is going to really come in handy here when it comes to these devices. So it can do up to that, and again, it even says right there it can do up to 35 watts per port. That means if you've and it can take, this switch actually works off of an input voltage. I would normally use it. I would normally use it for 24 volts, and if that's the case, as the operating range of 12 volts to 36 volts. Again, it doesn't quite work for 12 volts because your battery may go lower than that. So I'd highly recommend using the 24 volts for it. And this is the other thing that we have people do frequently that oversizes their system unnecessarily, is even though, so they may have a switch, they may have a PoE switch and saying, yeah, I have a 140 watt switch. As you can see there, it can do 140 watts. That's total though. That would mean that every port is operating its maximum, and that's not normally the case. As I mentioned earlier, you're going to have, cameras have a max and they have a typical. So even though your switch may be able to do 140 watts, that's not what the system would normally be consuming. It's be consuming a lot less than that. So we get this frequently. People come to us and say, yeah, I've got a 140 watt switch. I want to design a solar system for that. And we have to go back to going, okay, what are you powering? What's your camera? What's your radio? What's your other equipment? Because frequently their system ends up not being 140 watts, but by the time we add up the loads, it's more like 30 to 40 watts. So if we would have done a 140 watt system for them, we would have oversized it and charged them for a system that was 3 times what they needed. So again, it's very important to understand your load, understand how it works, and then be able to size the system according to that load correctly. I also want to point out that these switches do have a self-consumption that has to be added into the load. In this case, that switch that I was mentioning, the IEEE one here for the 24 volts on the input is going to consume 4 watts. So I would add that 4 watts into my load calculations as well. But again, that's dramatically less than say 7 watts for the inverter, plus the losses of the inverter, plus everything else. So plus you would still need a switch anyway. So just something to look at. And again, the injectors are the same way. They're all going to, I'm going to show you other slides that are going to show that that power consumption here. Here's another example of a switch, and this one has some of the network standards in there, 10 base T, etc. I'm not going to worry about that kind of stuff, Ethernet protocols and whatever, flow control. What's most important again is the power requirement. That's what I come back to. Again, it can take an input of 12 to 36 volts. So I would again recommend a 24 volts input for this because that battery range is going to be perfect for this operation. This can do up to 30 watts per port. Again, because it works on the if I go up above, it's the standards that has 802.3 AT, so it works in the AT standard, so it can do up to 30 watts per port. And again, even though it has a power consumption of 145 watts, that's the full power consumption. That's not the idle, and that's not the typical. That's max. So again, this one's not showing on what I've shown here. It doesn't show the self-consumption rate. You may have to look deeper into the specification to find that. If you can't, then contact a manufacturer. A lot of times they'll have information that's not published on a spec sheet. Sometimes they may say, it'll take a 12 volt input or a 24 volt input and not give you the range. So sometimes you may have to contact the manufacturer for additional information if it isn't published on their spec sheet. But generally, most of what you need is there, but not always. So sometimes you may have to contact them and get that information if it's not already present on their spec sheets. And when I've done that, by the way, I usually say, hey, it'd be handy to have this stuff in your spec sheet. Next time you update it, you might want to put it on there so somebody doesn't have to ask you for it later. Let's talk about injectors a little bit. Here's the same thing. Here's a device that can be, they've got 2 different versions. Again, they got the passive version and they've got an active version. Again, this uses the IEEE 802.3 AT standard. And this one, even though it does a max power output of 70 watts, you may not need all of that. Again, you have to go back to whatever the device needs, not what the injector can put out, but what is the target device actually going to consume. So you need to go back and look at that. And note the self-consumption on the injector is 2 watts. So a lot of times going with the switch is going to be more, going to be better on your load consumption than an injector because you have multiple injectors. If you have 2 injectors, now you're already at 4 watts. So you can use a switch instead. You're going to have less self-consumption losses of those devices. So generally, I try to go with the PoE switch if possible. Again, that's not always possible depending upon the load, but if you can, it's usually going to be more cost-effective and a better solution for you. Okay, let's continue with some with injector options again. Here's another one. And this one has a huge wide range on the input voltage. It can run from 9 to 48 volts DC on the input. Its self-power consumption is a little higher though. It's 5 watts. And its max output is 60 watts on the PoE port. But again, that's just what it puts out. That doesn't mean you size or design for that. You're going to size and design for whatever the camera or the radio or the light or whatever it is needs. Now, what's interesting is that here's another device that would have operated similarly with a much lower self-power consumption. It only does 1 watt, and it can put up to 97 watts on the output line. So that sounds pretty cool to me. Like, that's a great device. Like, not only can I do more power if I need to, In addition to that, it's got a lower power consumption. But my issue is when I go to look at the input voltage, it only operates from 53 to 57 volts. That's not going to work on a 24-volt system, and even for a 48-volt system, because in a 48-volt system, my battery has a nominal 48 volts, so that's not going to work. So even though this device may look great, probably not going to work for my solution. So again, look at all of the specifications. You want to look at everything. You want to look at the standards that it's using. In this case, this works for all kinds of PoE output. It works for the AF, the AT, and the BT. So this can do the high power if you need it. But again, because of that limited operating voltage as opposed to the one above, which has that wide input, even though it has a higher power consumption on it, it's still probably a better option because it has that wide input operating range. So again, look at all of the spec. Okay, so now let's actually go through a couple of system examples. Oh, and by the way, if you have trouble trying to figure out these spec sheets, I know there's a lot of information there and sometimes they hide that stuff. Feel free to contact us. Contact Solarflexion, contact myself, and we can go through, we can figure that stuff out. We frequently have to ask people for the spec sheets or for the model numbers of the equipment you're using, and we can go through and figure all that stuff out for you, size it, design a system that works for your application. That's pretty much what we do. That's what we do day in, day out. That's our bread and butter. So, if some of this stuff seems a little overwhelming or a little, complicated to you, or you're not concerned, or you're confused, or you're concerned you may not get it right or whatever, we're here to help you and support you on that. But for those of you who think you might be able to do it on your own, or you've been doing this stuff for a while, you've got some of this information already. We're going to go through a couple of typical examples of how you can do it, and then use some of the standard systems that Solarflexion has. So here's a really simple low power example. You've got a 1-watt cellular modem, and I know people have said to me before, do cellular modems really consume that little power? My answer is yes, they do. And the reason is, think about what your cell phone consumes. Your cell phones actually don't consume that much power either, because you don't want to be broadcasting a whole lot of power right next to your head. So a cell modem is no different than a cellular phone, other than the fact there's just no speaker and there's no microphone, but they're very similar in that regard. So they have a very low power consumption. Now, if you start adding the Wi-Fi to it and the other stuff that goes along with it, yeah, it's going to go up to 7 or 8 watts. And we'll have an example of that in just a second. But for just the modem itself, it is pretty low. And we're going to use a PTZ camera here. As you've probably seen from the previous slides, the wattage on those typically is right around 11 watts. And we're going to use a PoE switch to power this all up, which is only about 4 watts for its power consumption. So that gives us a grand total of just 16 watts. Not the biggest system, pretty late load, so we can easily power this up, no problem. Let's say that we have to have a Wi-Fi radio for whatever reason. That's we're going to consume about 8 watts on that radio. We've got a PTZ camera in there, consumes 11 watts. We want a thermal camera as well. We may have things that we may want nighttime mode with that, or we may have, I don't know, you want to try to shoot, picture things through a camera or through a fence. I don't know. So you may want a thermal camera in there. And again, we're going to use our PoE switch with about a 4 watt power consumption on it. That's going to give us a grand total of 28 watts. Let's go to something that might be a little bit bigger. We're going to use a mobile router, which is different than just a cell modem, because that router has additional ports on it. It also has Wi-Fi capability and some other stuff. So it's going to consume more energy. It's going to consume 15 watts. We're going to put a couple of PTZ cameras in there. We're going to want to be able to say, have a greater range of operation. We might want to, be able to sweep, like 320 degrees or something like that. So we're trying to capture multiple angles from multiple views. So we're going to have additional wattage there with those two at 11 watts each. It's going to be 22 watts total. And then again, your switch consuming 4 watts for a grand total of 41 watts. As I mentioned now, Solarflexion has standard systems ready to go that can meet any one of these examples. And Rebecca's going to come back in to talk about those in more detail now.
Thanks, Rob. So this is a copy of our brochure that we currently have explaining the PoE systems that we carry. And then, as Rob mentioned, currently we have 2 standard WAVE PoE 24-volt systems. They're listed on our website under off-grid WAVE PoE. Rob, can you go to the next slide? You can see that we have the 2 systems noted, and these can accommodate the kind of loads that Rob was just mentioning. So the WAVE 360-224 that powers up to 25 watts would work for examples 1 and 2 that he just went over. And the WAVE 723 124 that powers up to 45 watts would work, for example, 3. Again, you can see everything that comes in the system here and what it covers, the PV output, our standards, the remote monitoring, everything that's included in these type of systems. We also know that each system can be unique and custom, so we're prepared for that as well. So we can work with you on that. Rob's going to go over some additional options in just a bit when it comes to custom, and we'll share that. But right now, we're going to go into the major components. So you can see on this list the major components listed. So you have your solar module or modules, your mounting kit, mounting solution, your battery, your array output cables, the enclosure, and of course batteries. You have your pre-wired backplate that includes the Morningstar charge controller and Ethernet adapter, PoE switch or injector, overcurrent protection, etc. As mentioned too, you'll get the drawings along with operations manual, tech support, warranty. We have troubleshooting if needed. The support doesn't stop when the order's shipped. We're going to be there for you when you need us. So you purchase a system with us, we're going to take care of you. What's not included in the system, as you can see right here, just a small little bit that's not included. Normally the mounting pole, it's normally a 2 to 4 inch pole. We can supply it, we just normally do not, but you let us know what you need. Again, we'll help you. What's not included as well is the civil works, load wiring, installation. Those are your responsibility. Again, we can recommend, we can kind of have some support, but those are things we do not do. And with that, I'm going to hand it right back over to Rob, who's going to talk about the WAVE PoE diagram.
Thanks, Rebecca. Yeah, and so you might be wondering, how does all this stuff go together? And here's just kind of a really simplified diagram of how it would work. You've got your solar module with the power lines that go into your Morningstar charge controller. We're using the ProStar, either the 15 amps or the 30 amps, depending upon how big the solar array is. And we are using the pulse width modulated version of that. We can use an MPPT, that's an option, but in most cases, the PWM version is more than adequate. For more information on the ProStar and that kind of stuff, I'd recommend referring to our other webinar we did a few months ago on the advanced features of the ProStar charge controller. So, and then that, of course, that goes to your battery. So you get your solar module going through your ProStar to your battery. And then you can see the load is going out of the ProStar and is going to in this case, the PoE switch. And then you will see that in this case, we've got the cell router or modem connected to the PoE switch, as well as our camera. And we're showing in this case a PTZ camera. Now you'll also notice that there's a Morningstar EMC1 Ethernet adapter that is connected to the ProStar and to the switch as well. And our philosophy is that if you've already got the communications there, because you're already monitoring the site from a security perspective, you might as well monitor from a power perspective as well. For the small amount of money to add that Ethernet adapter into the system to get you that kind of information as to how the system is performing from a power perspective is very helpful. And you can go into data logging and things like that. You can monitor all kinds of stuff. And again, I refer you to the ProStar webinar we did a few months back regarding all that stuff. There's a whole section there about troubleshooting and what you can do with the log files and stuff like that. But again, so we've included that in here in the system because, again, we feel that's very helpful to understand what's going on with everything. So that's what's in a typical WAVE PoE system. Now, here's some options that you can have. Again, we're typically designed for 24 volt because it seems to work with everything. However, that may not be all cases. So if for some reason we need to do a 12 volt or a 48 volt system, we could do that. The other option is to add DC-DC converters for those loads. We can do that as well. If you have a higher PoE load, we can design a system, for that as well. So we can again tailor it to whatever your loads are and increase or decrease as necessary. As I mentioned, MPPT chart controller is an option as well. We have other load mounting options. If you've got loads that can be DIN mounted, we can add additional space on a DIN mount for that. So we can include space for that if you want to mount the radio. If you've got radios and other equipment that want to be installed in a box, we can find space for that. As I mentioned, there are some times when you just have to have that AC for whatever reason, so we can provide an inverter if needed. There are other battery options as well, if need be. And again, other solar module options as well, and other mounting options. You might want to ground mount for some reason, or mount to the side of a building or whatever. So we have other mounting solutions for that. There are other enclosure options. We can do a ground mounted if needed instead of a pole mount. We have other PoE switch and injector options. I'll come back to some of that high power stuff. Our standard wave includes the AF and AT, so we're not doing the larger BT type of loads, which are that high powered, say 60 and 90 watt stuff. But if that's what you have, we can include that as needed. So we can include those injectors if required. We can provide the cameras. We are not including the cameras, by the way. We are not including that. We are also not including the cell modem or the routers, but we can if you want to. So there's options that we can include that equipment if you need that, and other wiring and accessory options as well. Also AC charging options. If you, for some reason, you've got a possible generator plug-in, or you're near AC lines and you want to have that option, we can add an AC charger as well, and many other options. If you can think of it, we can probably find a way to do it for you. Now, here's actually, I had just mentioned the AC charger option. This is actually a UPS system we did for a customer recently, and so this is something we could do. This one actually had a couple of those high power PoE injectors that were needed for that load. You'll notice even on a UPS application, we still included the ProStar and the Ethernet adapter, and that was so that we could monitor the power remotely. This way they can monitor and see if the AC power went out, and they could also control the load remotely too if they wanted to. They could shut the load off if they wanted to for some reason, or things like that. So we included that for remote control and monitoring. So that was pretty neat. A light pole is another option as well. We see that frequently. A light pole is basically just kind of a daily cycled UPS. What happens on a light pole is that there's only power at night when the lights come on. During the day, there's no power. Because that's shut off somewhere else on the line. A lot of times you'll have 10 or 20 lamps all connected up to one photosensor. So these lamps don't actually have power until nighttime. So what we can do is we can set up a UPS system that basically recharges from the light at night when the lamp is on, and then when it shuts off during the day, we just discharge the battery. So it's basically a daily cycling UPS application. We can do that too. So again, whatever your applications are, contact us. We probably got a solution for you. So we've heard us mention the load multiple times now, how important and critical it is. Solarflexion has a load worksheet that they can send you, and you can go through to help fill out that information, include the spec sheets, any other information you have, so that we can be able to size a system for your application to make certain it works correctly for you. And as Rebecca mentioned earlier, we do size industry standards. The industry standard, if you're not aware of it, for standalone or off-grid solar systems is IEEE 1562. I'm just going to talk just a little bit about some generic system stuff, just so you're aware of it. Shading is a big issue, and you really don't want any shading at all if you can help it. Any shading is an issue, and the reason being is all those little cells inside of solar modules. Most solar modules are made of little cells, and they're all wired in series, and depending upon the voltage in the module, you can be anywhere between 36 cells and 72 cells, all wired in series. And the problem is, because they're wired in series, the current going through each cell is the same, and if the current's limited in any one of those cells, then the current through the whole module is limited. So what that means is, if you shade a single cell, then the output of the entire solar module can go to 0. So again, you really want to have no shading if possible. So and by the way, that photo, that's actually the solar module. It's a system on my house. It was for a pond aerator, and you can see that vegetation does grow up and cause a problem. So that was a cue to me that this spring I needed to go and trim up those bushes a little bit to have my aerator working again. So even the best of us sometimes neglect maintenance, and this is what happens: you neglect maintenance, you get bushes growing up over your solar modules. Next thing you know, your system's not working right, and that might be the reason why. And actually, I'll talk about troubleshooting in just a minute, so that's kind of a good lead into that. But I think first we're going to cover maintenance. And maintenance is really fairly simple in these systems. They really don't require much. Solar modules themselves really only need to be cleaned if there's something caked on it, like bird droppings or mud or something like that. Small amount of dust is fairly normal, and generally the rain can just wash that off. If you're in a desert climate, maybe parts of Texas, Arizona, New Mexico, or even Southern California, where you do get a high buildup of dust, you may want to occasionally wash it, but for the most part, it's generally okay. Sometimes just visually inspecting the system, you'll find something that might be wrong. You might find a wire that got chewed through by a mouse or a rat or something like that, some type of rodent, a squirrel. So you want to look for those types of things. Chafed wire maybe from the wind blowing a cable around. And if you see that, you either want to try to fix or repair the wire, or if it isn't bad yet, maybe just secure that wire better so it's not flapping around in the wind. Add a few more cable ties on there. That's another problem is cable ties do break. Despite the fact they're supposed to be UV resistant, they do kind of degrade in sunlight. So if they break, you might want to put some fresh wire ties on there or some other method of strapping wires down, especially from that solar array to the enclosure. It's not flapping around in the wind. Again, you want to look for any types of loose connections, things like that. It's also helpful to check the output of the charge controller. As I said, we try to use the ProStar and other Morningstar products. Most, especially the ones that have communications and data logging capabilities, if you can download the data and analyze it, that's really helpful for figuring out the health of the system. So we do recommend that. And again, if you've got the Ethernet adapter, like we recommend putting in there, then you can even do all that remotely. So sometimes you don't even need a lot of maintenance because you can monitor the system remotely and see how it's doing. Although generally we do recommend visiting the site at least 2 to 4 times a year. Quarterly is great, but at least quarterly or seasonally is great, but at least spring and fall would be my minimum recommendation on that. And again, let's again, I mentioned troubleshooting, and again, one of the first signs that the problem is the load's gone offline. That's typically the classic one. I would say if you can, check the output terminals of the charge controller and see if there's voltage present. If there is, check the PoE injector or switch, whichever you have, to see if there's something that's gone wrong there. Or, and if you've lost communications, you may have found your cell modem has gone bad. I had that happen with a client recently. I was working on one of these systems for them, and he had thought the batteries had gone dead. As it turns out, the batteries were fine. As it turns out, the cell modem had gone bad. So we ended up just swapping out the cell modem. System is back on and good to go again. Oh, that also reminds me, there are options on cell modems too. There are single band and dual band, and what that means is that the dual band means you can have multiple cellular carriers for even more reliability. So you could have like a Verizon SIM card and a AT&T SIM card in the same cell modem. So that allows you even greater reliability in areas that may have spotty service. So I would look for that. If there is no voltage at the output of the charge controller, then that means the charge controller is in low voltage disconnect, and you may have had the bushes grow up over the solar module, something like that. So I would try to find out what happened. Maybe a rodent all through your array cables, maybe a wire came loose, something like that. So I try to go through the system and figure out what happened. And if it turns out that everything was fine on the solar array side, then you may want to look to see if maybe the load is greater than it was designed for. Maybe you're panning, tilting, and zooming the camera too much, or maybe there was a heater you didn't know of on the camera. Some of these cameras have heaters in them, and you forgot to disable it, and it's running frequently in the wintertime, and that's causing a problem. So, or maybe you forgot to disable the Wi-Fi on the cell modem. I've seen on the cell router. I've seen that happen too. Again, I'm just trying to cover some of the common stuff that I see of what can go wrong and what to look for with these things. Okay, let's see. I think I already covered some of the stuff already. Again, the wiring, the shading, the tilt angle. Oh, that's another one. An orientation. Sometimes in a high wind location, if you didn't tighten the clamps down on the pole clamps down at tight enough, I've seen the wind literally blow the solar module to the side. So you may want to just double check that, make sure it's still facing south. Again, I've already mentioned checking the load usage. If you do have issues and the battery is more than 5 years old, it's probably nearing the end of its life, so it might be time to replace that. If it's younger than that, and you're using a good quality battery, like we would use, but I know some people use some of the cheaper ones. Some of the cheaper ones only last a couple of years, but I'd recommend it's a better value usually to go ahead and spend the money for a better quality one that's going to last 5 years or more. So if you're getting less than 5 years out of your battery, you may want to check and see what's going on there. And one of the best ways to do that is, like, as I've mentioned several times before, is just download and review that log file. A lot of good data in there. If for some reason you've downloaded it and you can't see what's going on, send it to us. We can analyze that for you. I've done that many times and be able to look at it and go, here's your problem type of thing, or at least help you troubleshoot it. Hey, narrow it down to look for this or check that type of thing, and try to help maybe, target the certain areas to what the problem might be. So with that said, I'm going to turn it back over to Rebecca, who's going to talk about some promotions they're running.
All right. Okay. As mentioned earlier, Solarflexion will be running 2 promotions for the month of May. The first one is for all of today's attendees. As our way of saying thank you, each attendee will receive a complimentary hour of sizing and design support when a load calculation form is completed. And then we can provide those forms upon request. So you just let us know if you're interested, and we will go ahead and start working on that with you, and then set up your hour of support. Also note that each attendee will receive an email from Solarflexion within 24 hours of this webinar. This email will include an interest form for those who would like to discuss any potential projects. Take a minute to review and reply to this email for a chance to win a $50 Amazon gift card just for returning that. The drawing and winner will be announced on Friday, May 14th at 12 p.m. Pacific, and again, we'll send out an email with that information. The second promotion we're offering is 10% off all Morningstar products for the month of May. Use promo code MSMay10 at checkout on our website, or mention this code when speaking to any one of our representatives. I want to take time right now to thank Mark with Morningstar and Rob with Solar System Services for working with us on this webinar, and also allowing us the opportunity to share information about our WAVE PoE systems. Thanks, guys.
All right, very good. Thanks for the terrific presentation, and we do have some questions that came in, so let's take a look at those. First question I see from Mike is, he asked, were those DC powered switches that you showed in the early part of the presentation, or were they AC? And could you tell us what's the advantage of DC versus AC?
Well, they were DC powered, absolutely. And again, normally we'll run 24 volts to those. Most of them had a wide input DC range of around 9 volts to 33 or 36 volts. And again, the advantages were we don't need an inverter, so we're going to save there in terms of energy consumption, and we're also going to save in terms of reliability and space in the box. So there's multiple reasons to not use an AC switch and use a DC switch.
Okay, great. Thanks for that question. Thanks for the answer. I see a question from Andres. He asks, let's see, when we're calculating our PV array, should we consider the max power consumption of the devices or the typical power consumption?
Good question. I would normally use the typical, and sometimes I might throw an additional factor just in case type of thing. But for the most part, as I said, with a lot of these cameras, it's kind of a set it and forget it type of thing. You might pan, tilt, and zoom when you're setting it up to try to target a specific area. You want to try to zoom in. You want to try to cover a gate or some type of entrance or something like that. And once you get it to where you want it, you pretty much don't touch it again. So then you're normally just going to use the typical. But just in case occasionally you might have somebody that wants to check it remotely, you might throw an additional fudge factor, maybe 10 or 20%. That's kind of at your discretion. But for the most part, I just try to use the typical, then throw a little bit of safety margin on there.
All right, very good. See a question from Chris, asks, what is the purpose of the injector, and how does that how does that compare to a switch?
The injector, so the PoE switch, the switch has 2 functions. The switch actually, you have one Ethernet line in that then connect to, 4 or 8 devices, or many ports the switch has. So the switch has multiple ports to go to multiple devices. So you can have a straight switch that has no PoE, and you'll find that that's common in network rooms, and in the old days we used to have them in our houses before we had Wi-Fi. You used to have network lines we used to have to plug into in the old days, or in an office type of thing. But now you can put the power over Ethernet on those lines through the switch. So now, if you don't need a switch, as an example, some of these radios actually can go, so you might not even need a switch, depending if you've got a single camera and a single radio. Sometimes you can plug the camera right into the radio and not bother having a switch at all, which would be one less thing to worry about. But you might not be able to get the power to the camera now because that radio doesn't do a PoE. So now you would put an injector in that line to power that device up, or you might find that your switch, for whatever reason, isn't compatible with your PoE load. Again, some of these high power ones, like some of these cameras have some of the thermal imaging or more or other ones may be a high power load where it's consuming, maybe 90 watts or 70 watts, and you have to use one of these high power things, and the switch just can't put out that much power. So you have to use maybe a high power injector instead. So generally, like I said, generally we end up using the switch anyway, just because we usually have more than just one thing plugged into it. Like I said, usually we'll plug the Ethernet adapter in or something like that. So generally we'll do that. But in that example I showed with the UPS system, we ended up using injectors, and that was primarily because the load wasn't compatible with the PoE switch. Now we still had a switch in there, by the way, and we ended up using a non-PoE switch that was DC powered. So that's just kind of an example of a custom design we did for that customer for that situation. So again, contact us. We're happy to help you with our solutions because not every solution works for everybody's application. We can tailor it to whatever you need. Again, that's a great one. We use a DC switch, non-PoE with injector separately because that load device, that target device, for whatever reason, wasn't compatible with standard PoE switches. We had to use a specific injector instead for those loads.
All right, very good. See another question here. Do inverters normally have an off switch?
Yes, they do, and a lot of them even have a remote off feature. Keep in mind though, even when they're in that off mode, the circuit board or something still may have a little bit of idle power to it, perhaps. So that's when you get in that like standby thing where I think it was like 90 milliwatts or something like that, which is still fairly insignificant. It's a lot less than the 7 watts it was consuming. But yes, most do of some form. Now, whether it's a hard thing where it's completely off or whether it's just kind of in a standby mode depends upon the inverter or how it's being controlled and stuff like that.
All right, very good. Let's see another question. How do I measure the operating watts on the MG90? I think that was on one of the slides, if I'm not mistaken.
Yeah, that was a router I had a client using recently that I did not recommend to them, but they had to use for non very good reasons. I'll put it that way, for bureaucratic reasons. And it had some very high power consumption, and they were able to disable some of the features they did not need to try to get that power consumption down. But there are a couple ways to measure it. The best way is to try to put in an inline monitoring device of some form, or in some cases you can use another device like as an example, I mentioned using the ProStars with the data logging. One of the things that's data logging is the load consumption. So you could use a device like that perhaps to monitor the load consumption and figure out what it's consuming. You could use an inline device of some form. There are specific data logging devices for that, but sometimes you can use a simple multimeter inline to measure that as well.
All right, very good. Thanks for that question and answer. All right, another question coming in. How many days of standby do you add to the battery? In the Northeast, we have to do typically 7 days, which could be a problem with off-grid. So
that is absolutely true and correct, actually. If you were, I mentioned the IEEE standard 1562 a few times for sizing. And by the way, Morningstar has a sizing webinar I did for them back a few months ago as well that can go into all that stuff in greater detail. If you want to, you can go to the Morningstar YouTube channel and look for that one. But yeah, that standard basically says you have a minimum of a 7-day battery in all regions, in all situations, in all applications. If you're off grid, minimum of 7 days. And then, I'm sorry, 5 days, excuse me, minimum of 5 days, all applications. Now, if you're in a climate with poor sunlight conditions or a critical load, and of course the Northeast is an example of poor sunlight conditions, then it recommends a minimum of a 7-day. So that would be correct. Now that's not a problem, really. We do systems with 7-day batteries all the time. It's not an issue. So, you might just need a slightly bigger battery box. We have solutions for that. So that would just be kind of a custom design, but not a big deal. Contact us. We'd be happy to help you with your application.
Okay, hey, here's a good question coming in from Kyle. He says, as the PoE voltage is about 48 volts, is it more efficient to supply your PoE switch with a 48 VDC PV panel controller system versus a 12 volt or 24 volt?
That's a great question. I don't know why, and I can't answer or explain this, but it seems like most of the switches and injectors that I have found have a common voltage range that works for 12 or 24 volts. That's it. And I'm not certain why they just don't have an input range that works at 48. There are some, by the way. I think I showed a couple of PoE injectors that did. So there's a couple of injectors that did, but for the most part, most of those devices are kind of in the 9 to 30 volt range, so to speak. For whatever reason, I don't know why. I don't make the injectors or the switches. I ask them what it is, but that's just typically what they use. So for us, it's just easiest to do a 12 or 24 volt system. And again, the 24 volt system just seems to be the most common for us with most of those devices.
All right, and Brent is asking a question about an economically viable PoE switch. So he says, can you recommend a reasonably priced vendor and model for 24 volts DC?
Oh my goodness. It's hard to, I mean, I don't know whether you need a managed or unmanaged. I don't know what the loads are that would need it. So I don't know what the load requirements are because I don't know whether you need the AT or the AF, et cetera, et cetera, et cetera. So I need to have more information on that, but there's at least 2 or 3 different vendors that we work with for solutions on that. So again, this is why we have that load sheet. We try to ask for you to send us the specification of those loads, of the camera, of the radio, and devices like that, so we can try to come up with the components that can work for that device. Because as I was saying, there's a handshaking going on there. So the power over Ethernet requires that both the switch or the injector has to work with that load. So you have to make certain that these two things are compatible with each other. And again, they've made it fairly easy though. If you look at the spec sheets, they have the information on there. You just have to make certain you've got both the switch, that works for that load device. So just check the specification sheets, make sure they both match up, and then you're good to go.
All right, good enough. I see a question here from Victor. Let's see, taking into account that some DC industrial PoE switches work on 12 to 36 volt range, have you successfully used PoE switches on 12 volt solar systems? And then he says, isn't 12 VDC very close to the minimum voltage supported by PoE switch?
We haven't done that too much. Generally, again, 99, 95% of the time, we're operating at 24 volts because, again, the equipment has that wide range, and generally, we end up having to have a couple of batteries anyway. So whether the batteries in parallel or series makes no difference. Same thing with the solar modules. And actually, generally, the solar modules and solar ends up being so big, we can use a less expensive 24 volt solar module as opposed to a couple of 12 volt ones. So generally the 24 volt system ends up being more economical too. So even though you could operate, say, at 12 volts, we generally end up going to 24 if it's allowable because it ends up being generally a less expensive system.
All right, very good. Hey, here's a question from Daryl. Daryl, I hope you're doing well. Good to have you here in attendance. Let's see. Question is, how much power can a Cat 5 or Cat 6 handle?
I will sort of say I'm not positive because I am not a network person, but from the research I did for this, it seems like you can do up to 90 watts, but you got to be careful on distance. And even then, you should use an injector closer to the load. If you're using the lower wattage stuff, like the 15 to 30 watts, generally it's not an issue, and you can go much greater distances. Like you can go like I think in some cases you can go like a couple hundred feet. I think actually almost. Before you need a booster or something like that. So again, it kind of varies depending upon and again, I'm thinking Cat 5, there's also Cat 6, which is even better. So it depends upon the type of cable you're using, the distance you're going, and then the wattage it needs. And again, I'm not necessarily an expert on that one, so that's not my specialty. But for most of our stuff is so close because again, we're in a box, so we're only going like 5 feet, if that. Even if you're going to go on a pole and up to an antenna, maybe 10, 15, 20 feet max. So generally for our applications, it's not an issue.
Okay, very good. All right, let's see. What question do we have in here? All right, looks like Benjamin's asking a question. I think we kind of covered this, but let's just go over this again. How many days of autonomy do you consider for these applications? And would this depend on geography and other factors?
Absolutely. Again, it does depend upon geography. Again, I'll refer back to the IEEE standard. Standard 1562. It states a minimum of a 5-day battery in all applications and all zones. And for areas with a critical load, I mean, I'm not certain how critical your load is to you, but for a critical load in areas of poor sunlight conditions, and I'll go again to the northeast and to the northwest, the Seattle area has horrible sunlight type of thing. So if you're like in that kind of area, or if you're up around Boston or New York or something like that, again, horrible light. And there's applications that recommends a minimum of a 7-day. Now, again, that's the minimum. You might find you really need a 7-day, a 10-day, or even a 14-day battery maybe to make your system reliable for that location and for that load. We can help you do that. We have ways to size it by either on paper by hand, or we actually have sizing simulators that we do use that allows us to, depending upon the solar modules used and the batteries being used, we can optimize the system for you. So again, contact us with your load information and we can size it for you to your specific location for your specific application.
All right, and it looks like the last question here coming from Todd. Question is, are the various systems generally closed loop with Morningstar?
I'm not really certain to that. I think if they're referring to communications, I don't really handle. I mean, that would be out of my.
Yeah, I think we might want to take that one offline
Yeah. I was thinking
and make sure we're
yeah. I'm kind of focusing on. I'm trying to focus on the power system here. That's a communications or network thing,
right.
and that's a whole other thing that I usually leave up to the networking experts, the people that are more knowledgeable at that than I.
Okay, well, very good. Let's see. I think that covers everything. So why don't we go to the last slide, which is the thank you slide. And you can see all of the contact information there for Solarflexion, Solar System Services, and Morningstar. If you have any questions or comments you want to send our way, just feel free to use those points of contact that you see here. Other than that, hey, Rob and Rebecca and audience, say thanks for everyone for attending. We'll wrap
Thank you.
things up.
Thank you, Mark, for hosting.
And we'll see you next time. This concludes the broadcast. Thanks so much. Take care.